All right, folks, sorry that I'm missing you today. Kind of wish I was here to help you out, but I hope this helps. This is going to be your answer key for this worksheet. I'm going to try to cruise through these problems and talk them through for you. And then we will, I'll see you when I get back, and hopefully we're doing okay. When I get back on Monday, you are going to have a quiz. So as you work through these problems, make sure you email me if you have any questions whatsoever. If you don't email me, if nobody emails me, I'm just going to assume you guys are doing well and not having any issues whatsoever with any of the questions or any of the things that we go over. So email me with your questions. First off, classify the following: sequence, series, finite, infinite, arithmetic, geometric, neither. This problem is just a list of numbers, so it's going to be a sequence. Secondly, it goes on forever because there's a dot 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 at the end, not in the middle. This problem is also arithmetic, and the D actually is 1/12, and you can verify that as you need to. Now the next question, this is going to be a series because it's added. And it is not infinite but finite because the dot 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 is in the middle, not at the end. Now this series is geometric. You can actually get that by taking -5/3 and dividing that by 5. You get a common ratio of 1/3. You can get 5/9 divided by -5/3. You'll again get that common ratio of 1/3. That's how you check. Now to list the first three terms of the sequence defined by that statement right there. For a sub 1, that means n is 1, so we put 1 in for n, and we evaluate it. So we get 2 times 3, which is 6. So the first term is 6, and we keep doing that for the consecutive problems. We put 2 in there, and we keep going until we get our answer. So you get your next two answers as 16 and 30, both like you put the n, or in this case 3, you put that in for n and you evaluate it. Write the equation of the nth term for the arithmetic and geometric series. You know this one's arithmetic because it's a d, that's a common difference. Because it's arithmetic, we know this formula. So we're going to get a sub 5 equals a sub 1. We don't know, but we know what d is. So we don't know we know that n is also 5. So then d is -4, and then we simplify this. We can also turn around and substitute -12 in for a equals 5. So we get, that's 4, so that'd be -16. So you get a sub 1 equals 4. And then we can put that back in to our generic statement. So we get a sub n equals 4 plus n minus 1 times d, which was -4. We also need to simplify this. A sub n equals, it's going to be -4n plus 8 as our closed form. So with the next problem, it's a geometric. We know that because there's a common ratio. So because it's a geometric, we have this. It's geometric, so we substitute these things into the general geometric equation. A sub n equals a sub 1 r to the n minus 1. So let's substitute some things in. A sub n would be 6. A sub 1 we don't know. R we know is 2. N is then 6 minus 1 up there. And then also we can substitute 8 in for a sub 6. So we get 8 equals a sub 1 times 2 to the 5th power. Now 2 to the 5th power is going to be 32. So we get 8 equals 32a times a sub 1. So 8 divided by 32 then is going to be 1/4. A sub 1 is then 1/4. To write the equation for it, we're going to take that and substitute back in and get our general form. So we get a sub n equals a sub 1, which is 1/4, times the rate, which is 2, to the n minus 1 power. Now you can't do 1/4 times 2, because if you did that, that would be blown out order of operations, and that's a problem. Now let's look at number 4 here. Okay, now this is a little bit of a different start. We're trying to find the missing terms of the arithmetic sequence, so we're trying to find two consecutive terms. Now we have to find what D is so that we can change it each consecutive one. Now there's a few ways to do this. The way that I'm going to go about is I'm going to name this A sub 1, which is the start, and I'm going to name this A sub 1, 2, 3, 4, 5, 6, A sub 6. Now there's a few different ways to do this. This is just the way I feel like doing it. Now, with an arithmetic sequence, you get A sub n equals A sub 1 plus n minus 1 times D. We're going to substitute some things in there. Right now, A sub 1 is 84. We know what n is when we're talking about this. So we're going to write n being 6. We don't know what D is. That's kind of what we need to find. But A sub n, A sub 6 is going to be 39. So we can write 39 there. And then we can solve this little equation here. Then we get 5D equals, we subtract 84, we get negative 45 is equal to 5D, so D is then equal to negative 9. So after we get negative 9, we just do 84 minus 9, which is going to then be 75 minus 9 again, which is going to be 66, minus 9 again, which is going to be 57, minus 9 again, which is going to be 48, and then it checks again down to 39. So we're in good shape. Done. Next problem. Find the sum of each arithmetic sequence by hand and then check it on your calculator if you know how. First, the common difference in this is going to be a plus 5, positive 5, so D is going to be positive 5. If we're doing the sum of 1, 2, 3, 4, we don't know how many terms there are. But what we do know is we know that that is equal to A sub n. We do know that this is equal to A sub 1. So if we do the sum of first n terms of an arithmetic sequence, which is this formula right here, and we start substituting some things in. We want to find the sum of n terms. We don't know, so we don't know what n is. But we do know what A sub 1 is. We're going to erase that and put negative 4 in there. We do know what A sub n is, being 91, so we're going to write 91 in there. We don't know what n is, but we do know that it's an arithmetic sequence, and we do know that this is the formula for the closed form of an arithmetic sequence. So we know what A sub n is. It's going to be 91. A sub 1 we said was negative 4. We don't know what n is. That's the variable we're going to solve for. The common difference we said was 5 just by looking at it. So then we turn around and we solve this equation. We get 91 equals negative 4 plus 5n minus 5. So we get 91 equals negative 9 plus 5n. Then we add 9, so we get 100 equals 5n, which means n is 20. So we're finding the sum of the first 20 terms, so we're going to replace that n in there with 20. And then we're going to calculate it. And we're able to calculate the sum of the first 20 terms as 870 for this problem. Now let's look at the next one. You guys need to be able to notice that this one actually is arithmetic. You'll also need to notice that your common difference, one little tidbit here, your common difference right there is also your slope when you write it in the closed form. It's also kind of your slope. So our common difference for this one is actually negative 4, our common difference. That's the thing that changes. That's the rate of change between the two values, and it changes by negative 4 each time, and that should make sense. We want to go from the first term to the 101st term. So when we're doing our sum of n terms using this formula, we know what n is this time, so we're going to put 101 in for n. What we're also going to do is A sub 1, we need to calculate that. So we use this closed form of the arithmetic sequence to find A sub 1. So we do 4 minus 4 times 1 equals 4 minus 4, which is just 0. So our first term is actually 0. We can actually use this to calculate our 101st term as well. So we get 4 minus 4 times 101, and then we get 4 minus 4 times 101. Our calculator, you get negative 400. And that's what we're going to write in there for A sub n. So then we go ahead and we evaluate that. So we do negative 400 divided by 2 times 101, and we get negative 20,200. Bam, barbecue pork. All right, let's take a look at the next one here. Find the first three terms of the arithmetic sequence defined by this. So we have some information. We also know that it's an arithmetic sequence. From an arithmetic sequence, we need to know that this is true. Okay, and let's see what we can put in there. We know a sub 1, which is 14. That is fantastic. We don't know what n is in this whole entire problem. That's okay. Ain't no thing. We can solve it. So we get n minus 1. We can put it in there. We don't know what d is either. So we're just going to leave it as d for now. But what we do know, we know that a sub n is going to be negative 85. Okay, so we know some information. We still have one equation and two variables, and that's a problem. So we need to bounce from using more information to use more information from that which we're given. We're given this and we haven't touched that. So if you remember what that means, that's from the sum of the first n terms, which is this expression. So let's see if we can put some stuff in there. S sub n is negative 1207 equals n. We don't know what that is. That's okay. But we know what a sub 1 is, and we know what a sub n is. Now we have an equation, one variable. That's what the n is. So we calculate that. So we're going to get, so we're going to solve this. So we get 14 plus negative 85 divided by 2, which is going to be negative 71 halves times n. And we're going to solve that by multiplying both sides by 2 over negative 71. So negative 1207 times 2 over negative 71, or negative 2 over 71, and we're going to end up getting 34. Now it's good that we didn't get a decimal in the final answer there, because if we got a decimal, that wouldn't make sense, because we can't have you know, a 2.5 term or a 51.8 term number. This is term number 34. So now what we can do is we can go ahead and we can put 34 in there. By the way, guys, again, when you're doing this, if you don't know how to start, just start somewhere and just start putting numbers in and just start cranking it out. I know it can be frustrating sometimes to feel like all these problems are different, which they are kind of different, but the concept is the same. You just start putting values in and solve a new equation here, solve a new equation there, and eventually you'll get to a point where you can solve one of the variables, and then you'll feel quite accomplished when you find like the d, the common difference. Now that we know the common difference, we're asked for the first three terms. Well, we have the first one. From that, we minus 3, so we get 11. From that, we minus 3, and we get 8. And now you feel quite accomplished in doing a problem that's seemingly difficult at the beginning, and maybe you didn't know how to start. But the fact of the matter is, just start putting stuff in the formulas that you know that are related to the vocabulary. The fact that it's an arithmetic series, and we know this from arithmetic series, and we know this from arithmetic series and sequences, and we can just bounce from there, put things in, and solve. All right, so number 7. Find the sum of the geometric series by hand. You can check with your calculator if you know how to. All right, these are geometric series. We do have a formula for that. That formula is sum of a geometric series. This is a geometric series. We have a rate in it, which is negative 1 from that problem. We have a first term, that's a sub 1, and we have an nth term that we're going to, which is 20. And we know that because the model of a geometric series is this. A sub n equals a sub 1 times r to the n minus 1, and that setup fits directly into that model. But we're talking about the sum of it, so we're looking for s sub n is going to equal to the formula a sub 1 times 1 minus r to the n over 1 minus r. So we're going to substitute the values that we know into the spot. So s sub 20 equals a sub 1, which is 9 times the rate, so it's 1 minus negative 1. Okay, and we need to put that in parentheses and make sure that minus is there, because otherwise we're going to ruin the order of operations. We know that 20 is our exponent, 1 minus r, which is 1 minus negative 1. Now to do this in parts, we get 9 up there. Negative 1 to the 20th power is going to be a positive 1. In the denominator, we're going to get 1 plus 1. So then we're going to get 9 times 0 over 2, which is going to be 0. So the sum of this from 1 to 20 is actually going to be 0, which is kind of crazy sounding, but it is. Now, guys, I'm actually going to talk about the next problem on the next video because I am out of time. So I hope you're doing well and you're having fun. Email me if you have any questions or concerns.